Thank you, and welcome everybody to the Data Science Workspace webcast. My name is Jeff Burke, and I'm a business intelligence and analytics consultant with Thorogood. I've been here for over 10 years, focused on BI and analytics the entire time. Feel free to reach out to me directly at my email or reach out on LinkedIn. Whether you have a question or not, I'd be happy to connect with the audience members on LinkedIn. So in terms of the agenda that we have for you today, we'll do a brief introduction on Thorogood, and then we'll get right into the Data Science Workspace in terms of what is it and why might you want one. And then we'll talk about some of the functionality that's required for the data science lifecycle and some of the more traditional challenges that people come across. We'll then talk about a customer example of setting up a workspace and some of the key considerations there. And then we'll end with some takeaways and how we might get started. For those of you who are new to Thorogood, Thorogood is a specialized consulting company in the area of BI and analytics. We've been focused in this area for about 30 years now, and it enables our consultants to develop expertise on the topics of BI and analytics to be able to consult for our customer base. We are a global company. I'm joining you from Philadelphia in the U.S. this morning. We do have consultants located around the world to service our global customers. In terms of the services that we provide, probably the most common aspect of our consulting is to come alongside a business goal or objective and provide an information solution for that, so the technology delivery of that. We also provide other services as well listed on the screen here, things like BI and analytics strategies as well as ongoing services. In terms of our customer base, we generally work for large organizations that have needs in the BI and analytics field. And certainly these four industries that we have on the screen are kind of data-rich sectors that have a lot of needs for our services. And we generally work across those four, but we also work outside of these industries on occasion as well. We are an independent company, and we work on behalf of our customers. And that typically means working across a number of different technologies to meet the ultimate objective of those organizations. So you'll see here that we work with many of the players in the BI and analytics field, and we have strong partnerships with these vendors to enable us to work with them on behalf of our customers. So getting into the topic of this webcast, the Data Science Workspace. So what exactly are we talking about when we say a Data Science Workspace? And I've defined it here as concisely as possible, but it's a workspace that defines an ecosystem in which a data science team has the freedom to explore the answers to impactful business questions. And that, of course, needs to be done in the context of security and doing that in a responsible way. But ultimately, we want to enable those roles within organizations. And why would we want something like this? Well, the short answer is that the answer to these questions can be really impactful for the businesses that the data scientists are serving. Another aspect of it is to kind of have a defined approach on how we define these workspaces is really helpful in terms of bringing together groups within organizations on what the overall approach is to be able to have these questions answered by these talented roles. So throughout the webcast, we'll go a little bit deeper in terms of what this workspace is and how it works. So before we get into some details about what the workspace is or what it needs to be, I thought we'd go a level deeper in terms of what the data science lifecycle might look like. And what I have on the screen here is a methodology that Thorogood uses for analytical use cases. And this is an industry standard model called CRISP-DM. And it's something, one of the virtues of it is that it's fairly intuitive in terms of reading the topics and the arrows going around the cycle here. The one thing that I will do is just call out some kind of key activities in this cycle so that we can best understand them in terms of the requirements or objectives to be able to enable the data science roles. So starting at the top here, and this is really the kind of start of the cycle, is defining a business case or question, preferably with a quantifiable business impact. So an example of that might be something like, if we can reduce our customer churn by 1%, it will mean $1 million in annual revenue to the organization. That's something that has a very clear business impact, and we could use data to explore how we might be able to influence that outcome. Working our way around the cycle here, we get to this data preparation phase, and this can potentially be a pain point for our data scientists. Initially, there needs to be some data acquisition, and that could take a bit of negotiation depending on who the holder of that data is, as well as the technical lead time of actually getting that data available. Sometimes those data sets, whether they're internal or external, could be in different formats than what we're used to, things like maybe Word documents or PDF documents, and almost all the time, typically pretty large volumes of information. Well, one of the key aspects to this data preparation step, and is typically driven by data scientists, are some of the transformations that are required in those data sets as input to the analytical models that will eventually run on these data sets. So it could be things like traversing through text documents and looking for particular phrases that we think will be important to the statistical modeling that happens in the next step. It could also be things like, in the example I used earlier, if we have a list of customer complaints, we may want to organize that information, say, per customer, how many complaints have they had in the last, say, 30, 60, or 90 days, to explore whether that has an impact on customer churn. And that's something that has, to some degree, can be defined kind of early in the business case exploration, but it may be something that needs to be iterative as well as we fine-tune models. When we get into the modeling and evaluation, this is when we're using that mathematical or statistical principles to be able to see if we can produce answers to the questions that prompt these cycles. And that may mean using new technology, and it often means using things like open source technology, or perhaps libraries that are available to the public, whether they're initiating from educational institutions or just collaborations in the field. There may be different tools for the job here. There's also typically a requirement to run these algorithms that are typically pretty resource intensive. They could draw quite a bit on computer resources for a defined period of time, sometimes hours, sometimes even days, based on the size of the infrastructure. So it could be pretty sporadic. And then once we get to a point where we can kind of evaluate our hypotheses on things, we can evaluate them. And it's very typical that that evaluation can prompt either additional business cases or perhaps a refinement of the experiment. And what we're looking to do in this cycle is to be able to enable those data scientists to be able to iterate and go through this cycle as quickly as possible, as quickly and effectively as possible, to be able to produce those answers. And once we have those answers, it'll almost certainly be a valuable conclusion. Whether that's a positive conclusion or even a negative conclusion, all of the learning is valuable. And that's the point where we look to kind of recognize that value, getting back to the business case, whether that's an answer to a one-off question or perhaps building in the analytics into more of a repeatable process within the business. So with that, drops out some requirements for data scientists. If we're trying to get them to iterate on that cycle efficiently and effectively, there's some requirements there. There's also some challenges that many businesses face if they're approaching it the same way they might approach other challenges that we have in the technology world, and we'll go through some of them here. So initially, kind of data acquisition. So scientists may need access to quite a bit of information, perhaps sensitive data as well. And there can be pretty rigorous processes around getting access to data within the organizations. And not to say that those are unfair. They are very fair, and they certainly need to be treated with the utmost respect. But we do need to enable the scientists by getting access to that information and ensuring that the scientists are secured in an appropriate way and that there isn't any information risk associated with their activity. The next one is related to data storage. So there might be a lot of data, and it might have some variety associated with it, and depending on an organization's maturity with this type of data, that could be something that's new for them to handle. Data transformation. So this is the place where we're doing a lot of the manipulation. We may very well be storing information, or there may be group or personal information that we need to pick up on. And oftentimes, a lot of these enterprise data stores are restricted to either read access, or there isn't too much freedom available for the data scientists to make those transformations or to perhaps iterate on those transformations in a way that they really want to. Next one on here is data versioning. So I think of this as almost the lab notebook that you might have in a particular course, but what you want to do is consistently be able to track your hypotheses, maybe the inputs and outputs of an experiment, so that you can go back to it either to repeat the experiment or to take an adaptation of it, depending on your previous conclusions. So that's something that's pretty useful and something that we would look to enable in a data science workspace. Technology, so the data scientists at Thorogood, the ones that we work with at our customer organizations, generally want to use things that are the latest available. This is an industry that's evolving pretty quickly, and there may be either software or even libraries that people want to draw upon as soon as they're out. And then lastly, performance. Oftentimes, a data scientist might start just working on kind of their own computer or own laptop maybe, and they'll run into issues pretty early in that process based on the sporadic nature and potentially pretty heavy compute demand that some of these algorithms have, and enabling that in a way that works for them is certainly one of the keys that we see to that life cycle. So now getting into a customer example here, and I'll use this slide to just set up this particular example, but we can also talk about it a little bit in terms of other customer circumstances as well. So this example is a data science team that actually had the scope of the entire organization. So they would actually pick up on business cases that were coming from any one of the business units across the entire organization. So a pretty wide scope here. And this is something that we've seen at other organizations as well, in particular having data science teams reporting directly into business units or even the CEOs of organizations. We've also seen it in other approaches where data science teams are embedded within individual business units and are a little bit more focused. They're really just two different approaches, but this one had, this particular example had a pretty wide scope. And that team, to kind of get started on their life cycle, they would identify and really qualify those use cases wherever possible, defining a business impact. So they really knew kind of what they were after in doing the mathematical or statistical exploration of the data that they have. And in this example, the data scientists were hitting limitations without having kind of a central workspace for them to use. And that was across a variety of places, but certainly from a performance perspective, they were running into capacity issues. So the objective here was to create a workspace that allowed them to kind of go through that life cycle, but also to do it in a secure and responsible way. We needed these roles to be able to get access to the information and be able to go around the cycle in a way that didn't introduce any sort of informational risk, and in fact even helped keep everything very secure so that they could, in fact, get access to these data sets and do the types, fulfill the activities that they needed as part of the life cycle here. So inside the workspace, if we use this methodology as kind of the background of the activity that's happening here, there are really three components that made up this workspace. I'll bring them in here. So one is the workstations that the data scientists would come in and log into. and the other two being kind of shared components, one being shared data of a couple of different types, as well as shared resources for the data science team, and we'll go through them each individually here. So the first thing here is workstations. So this is where the data scientists would log in and they'd have some client tools available to them. And those tools would generally fall into a couple different categories, one being visualization, one being data transformation, and the other being analytical modeling. And I've listed out some example technologies there that will help facilitate those things, but again, just being client tools that allow them to interface with the other shared components. Some of the considerations here, you may ask, well, why would you have workstations within this ecosystem rather than just having them log in from their own machines? I think one of the important considerations here is that there is kind of data transmission happening between the shared data and shared resources. And that's something that you, want to make sure is secure. You'd want to keep that in kind of an isolated area rather than going across the network of the entire company or perhaps even the internet, as well as a performance consideration. You want those clients to be able to interact kind of on a low latency network with those other resources. There's also an aspect of security here as well. We could define kind of a single pathway for the data scientist to get into the workspace, perhaps even have a separate login for them, which further enhances the security. And that way, any data or anything else that lands in that ecosystem is very contained and helps reduce informational risk as it relates to this particular workspace. Moving on to the shared data here, and that it generally fell into a couple of different categories. Internal data, so information that's originating from sources within an organization, and those were generally things like databases or perhaps files that would come through. External data, which is very common in data science use cases, to have kind of third-party data, whether that's demographic data, weather data, et cetera. And this can also be, these data sources can also be pretty large and varied in terms of the formats that they come in. And then the next thing on here is kind of group and personal data. And that's something that is particularly relevant to data scientists that are doing transformations and preparing data as input into models, as well as kind of saving their lab notebook of these experiments so that they can go back to them at any particular point in time or perhaps adapt or extend something here. So a couple of considerations across them. One thing is sometimes there's a reluctance to copy around some enterprise data, and I certainly understand that. However, the cost of data has been reducing, and to get these data scientists what they need, it is potentially possible to provide copies of information. I would suggest that they're kind of read-only copies of information. That way we still maintain that one version of the truth, but we also get the data scientists the kind of full fidelity of transactional information that they may need to kind of find that needle in a haystack. If there is sensitive data, of course, the negotiation of getting access to that sensitive data needs to be a discussion with data owners. However, the more secure and defined we can make this workspace and work on the principle that data only comes into this workspace and is limited to a set group of individuals and it's highly secure and that data doesn't come out of it, is a way that we can kind of negotiate access to that information. The other aspect of it is that the information can be anonymized or obfuscated, meaning that we can eliminate any personal data associated with it so that it's still rich enough to be used for analytics, but also has lower risk in terms of that information being sensitive. And then lastly, one of the potential objections that we could have around giving data scientists the freedom to store and transform their own data is the explosion of data that may cause. And I think that's a very relevant concern. The aspect that I would advocate for to kind of mitigate that risk would be to make sure that there's some personal responsibility associated with any individual data or data stores. So for example, if we provisioned a database for a data scientist, maybe put their name on it so that they have kind of a defined space to be able to use that they manage the same way you might manage the files on a hard drive. And if it does need to be reduced, or if that person leaves the firm at some point, there is a path to be able to clean that up so it doesn't put strain on the organization. And the last thing here is, are the shared resources. And the one that I'll focus on the most are the analytics processing resources. And that's really to enable a team of data scientists to be able to use potentially high-performing and scaling software and infrastructure to be able to run their algorithms. One of the technologies that we use for that is Microsoft's machine learning server that works well with RStudio and the R language. In terms of some of the considerations on this as well, there's definitely a consideration around managing the resources for performance, depending on how the team is defined and what they need to be able to do both on an ongoing basis and for any particular business case. There are considerations about how we define those resources. So, for example, we may not want any one individual user to be able to exceed a particular threshold from a performance perspective, but we also definitely want to get the kind of portfolio theory of having the entire team using a shared set of resources when it comes to analytics processing or even some of the other components that are out there. So how does this workspace kind of sit alongside other enterprise components? And the first thing that I'd suggest here is that the data science workspace sits alongside what we might have defined for a traditional software development lifecycle. And the reason for that is that they're really trying to service different objectives. And you wouldn't want to kind of commingle them and potentially compromise either one of those objectives. So the typical approach for a development, test, or production environment, or perhaps many environments as part of an overall quality assurance process, you really want to maintain the integrity of the testing that goes on throughout. Data science workspace is really set up differently and probably using production or production-like data. And we also want to enable that group without placing any constraints on either the data scientists or our developers releasing kind of a high-quality software. We would suggest kind of putting high walls around the workspace and ensuring that's secure. And that's for a variety of reasons, of course, data security being paramount, but also to be able to get data into that workspace and keep it to a defined user group and defined area. Kind of helps with acquiring data for the data scientists to use. In terms of how the workspace may interact with some of the traditional components here, we would potentially be getting production or production-like data to come into the workspace, whether that needs to be kind of live production data or perhaps on some sort of latency, maybe weekly or monthly data. It really depends on the business cases, but there are many cases that don't necessarily need up-to-the-minute live production data for the use of exploring them from a statistical or mathematical perspective. The other direction here is that once we define those deployment scenarios, once we come to a conclusion that may be valuable and may need to be incorporated into a more farther-reaching system, for example, we can kind of take those outputs or those learnings from the data science group and put it on a track to deliver a robust or kind of high-quality adaptation to one of the solutions that we already have. One of the last parts I wanted to speak about here is whether or not this is considered on-premise or in the cloud. In a lot of ways, this decision will be very relevant to, or will depend on an organization and exactly what those objectives are, but I've spelled out some of the considerations here. The aspect of this being kind of a self-contained ecosystem does potentially make it portable, whether that starts in a data center or is defined in the cloud. If it is fairly self-contained, it may not matter too much kind of where it goes and may in fact lend itself to be an early use case for the cloud. The next two on here are pretty important topics, first being data transmission. So if you have a lot of data that's being transmitted into this workspace, depending on where that data is coming from will be a consideration. So if a lot of that data exists on-premise, it may make sense to keep them close to one another. However, if a lot of that data is originating outside an organization's walls, such as external data sets, it may make more sense to put that into the cloud. Data sensitivity, of course, is always paramount, and that may play into the on-premise or cloud decision, or may even play into what components in the cloud or what technologies are made use of. So, for example, from a data storage perspective, do you use a common platform to be able to store data, or do you really need a private or isolated data storage mechanism, even in the cloud, for particularly sensitive data? The last 3 points on here, I think, are really points that may make the data science workspace suitable for the cloud. So elasticity, the ability to scale up and down the compute resources based on the algorithms that our data scientists are running, as well as the space requirements for different data. The cost model, it being a subscription model, and potentially being able to ramp up resources or bring them down based on the business impact of our business cases. If we have a business case that may mean multiple $1 million of returns income to the organization, we may not want to pinch pennies on the overall resources that are provided to this group. And then lastly, technology availability. There are some analytical tools that are only available in the cloud, but even technology that's available both on-premise and in the cloud, a lot of those cloud platforms make it pretty easy to be able to introduce new technologies into environments, probably even easier than on-premise, and that may make it particularly suitable for the cloud. So to wrap up here, I thought I'd just talk about a couple of key takeaways and how we might get started. So the key takeaways here are data scientists may be somewhere along their journey already, but if they're starting to hit limitations in their working, it may be time to have a look at a workspace for a team that's an ecosystem that really enables them to do what they need to do. Defining the objectives of a workspace and an overall approach could be a good way to get many different groups within an organization kind of on the same page and bought into how we might approach this and why we might approach it. And then lastly, we kind of worked backwards or worked to the key functionality that a data scientist is looking to do. And if we think about that objectively, that's something that we can most certainly fulfill within an organization and apply things like security and make sure that the data is contained within these workspaces in a responsible way. So how might we get started? I mean, the first thing is that's really required to go anywhere with analytics is to make sure that we have a business case for it. That's where the return on investment will be for both the data scientists and any resources to support them. And then from there is to kind of define the objectives as they relate to your organization, the methodologies that the data scientists are using, and anything in particular related to the business, and then an approach for the data science workspace. And that's something that Thorogood has helped our customers with, and we'd be happy to help the audience participants with as well. Thank you, everybody, for joining. I've listed my contact card up here. And as I suggested earlier, if you have any questions or want to reach out, feel free to send me an email or connect on LinkedIn. Thank you.